Alright guys, here's part 3 of your CBA full review. We left off on number 13, and number 13 says find the area and circumference of circle. It should say of the circle or the given circle or whatever. Excuse me. It just says find the area and circumference of the circle. Alright, so obviously we're talking about this circle. Notice we are given 24 inches is the diameter, so we can find area, circumference, all those things, no problem. Alright, so first area, remember area equals pi r squared. Right? So then the only thing we got to be careful of is that we're given the diameter, right? So we know half of that will be the radius, okay? So then area will equal pi 12 squared. 12 squared, right? And then last step, area equals 12 squared is 144 pi. Okay? If you got to the final answer on a multiple choice test, you didn't see 144 pi, remember you can probably try actually getting the approximation in your calculator. So 144 times pi, second caret is pi, and you'll get 452 as an approximation, so you can round that decimal. So that may be the answer choice. A lot of times we like to keep it in terms of pi, so just understand both. There's the bell for second period. Sorry about that. Alright, so then the second part, we got to find the circumference. Okay, and remember we have two formulas for circumference. The first one is C equals pi times D, and the second one is C equals 2 pi r. We could use either one, but because we're given diameter, well, we might as well use this guy, right? So then C will equal 24 pi. Okay, and again, if you didn't see that answer on a multiple choice test, well, you know just to do 24 times pi in your calculator and get the decimal, and that would probably be your answer. Alright, so let's keep on moving. Alright, 14 says visitors at a school carnival have a chance to toss a beanbag onto a circular tabletop that is divided into equal sectors, as shown. Visitors win a prize if the beanbag lands in the shaded region. What is the area of this sector? So they want the area of the shaded region in square inches round to the nearest tenth. Okay, and there's two ways we can find this, right? And I'm going to show you both ways. The first thing we can do is find the area of the complete circle. So area equals pi r squared. So then the area will be 18. 18 is our radius, so pi 18 squared. Okay, and then our area will equal 18 squared, 324 pi. Okay, so we can find that area, and then since we know we have equal sectors, well, we can divide that area by how many sectors are 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11, 12 sectors. We can divide that by our 12 even sectors because they tell us in the question that they're equal. Okay, so we can just divide that area by 12. So put that in the calculator. Again, I'm going to put 324 and pi in parentheses together just to make sure they do our order of operation correctly. Divide that by 12. And we'll find the area equals 84.8. So area equals 84.8. Again, so we just found the area of the complete circle, and since we knew we had 12 equal sectors, we just divided that number by 12. Okay, that's one way you could have found it. The other way we could have found it is using the area of the sector formula. So then area equals, remember it's x over 360, x being the degree measure of whatever your sector is, and then times area, so pi r squared, right? Sorry about that. Alright, so then plugging in what we know. Okay, so the x has to be whatever the measure of your sector is, right, in degrees. So that would be 360 divided by 12. Okay, so that would be 30 over 360. And then times the area, times pi, again, r is 18 squared. Okay, and this guy we can put in our calculator just as it's shown here. Okay, we can put that whole thing in the calculator. I'll show you how to put it all in there without making a mistake. Right, so again, we need to put this fraction. We'll do the fraction first, put it in parentheses so that we do the order of operations correctly. So 30 divided by 360, and then times pi 18 squared. So it looks exactly like it looks right here in the problem. Okay, and we'll find that we'll get the same answer we got before. Area equals 84.8. So just two ways to work this problem. Whichever way you feel more comfortable with, you can roll with, but you should understand both of them. Okay, so moving right along. We got 15, and it says, which of the following polygons sum of the interior angles is equal to the sum of the exterior angles? Okay, so we're given three polygons. We got a triangle, we got a pentagon, and we got a quadrilateral. They want to know when is the interior angles equal to the sum of the exterior angles. Well, we know that the sum of the exterior angles, this guy right here, it's always equal to 360, no matter what polygon we're talking about. Okay, so all we need to do is look at the sum of the interior angles of these guys, see which one of them's 360, and we'll know that that'll be the one that's equal. Okay, that'll be the only time that the interior angles equal the exterior angles. Okay, so looking at the first one, remember our formula for that guy is n minus 2 times 180, and n being the number of sides. Okay, so looking at A, right, it's a triangle, so we got 3 minus 2 times 180. Well, that 3 minus 2 is just 1 times 180. That's going to equal 180. Okay, so that's not equal to 360. Looking at B, it's a pentagon, so we got 5 minus 2 times 180. 5 minus 2 is 3 times 180, and that's equal to 540. So that's also not equal. Okay, when we look at our last guy, he's a quadrilateral, four-sided figure, right? So it'll be 4 minus 2 times 180, 2 times 180, and this guy will be equal to 360. So C is indeed our guy. Okay, so quadrilaterals, a four-sided figure, is the only time that the sum of the interior angles and the sum of the exterior angles is equal. Okay, very important. Alright, so keep on moving. Alright, so number 16, it says find the measure of angle R. Okay, so we're given this angle R right here, and we see it's an exterior angle, right? It's an angle on the outside of the circle, so the formula that we have for that is the measure of angle R will be equal to 1/2 the difference of the angles, right? It's, sorry about that. The way the book shows it is 1/2 of x minus y, right? But it's just the difference of the arcs. It's the difference of these two arcs. Okay, and we know when we do the difference, we got to do the big minus the small so that our answer is positive. Okay, if you did small minus big, you get a negative number, and you knew that was wrong because this angle couldn't be negative, right? So plugging in these guys, measure of angle R will be equal to 1/2 times the difference, 101 minus 39. Okay, so then 101 minus 39, that gives us measure of angle R equals 1/2 of 62, right? And then measure of angle R will be equal to 31. Okay, so just applying our formula that for the exterior angles, to find the angle, it's 1/2 the difference of the arcs. Okay, no problem. And then we got one more like that. So let's go ahead and rock and roll on that one while we're talking about them. So again, we got this guy, this measure of angle Y is what they want. Y is one of those angles on the outside of the circle, right? Creates those two arcs. So we know our formula is going to be measure of angle Y equals 1/2, again, the difference of these guys. So X minus Y. Okay, and we know we got to do big arc minus small arc. Okay, so let's measure angle Y equals 1/2 105 minus 63. Okay, and the measure of angle Y equals 1/2, and 105 minus 63 is 42. Keep on hitting that little thing on the sidebar with my hand. Sorry about that. That's going to be 42. Okay, and then we'll find measure of angle y equals 21. Okay, so no big deal at all. Should be easy money on the CBA. All right, so I'm going to stop right there. We'll pick up with number 18 on part 4 of the CBA review, and we'll probably rock out the rest of it. All right.